we've asked Mr. McEnroy, I think you know Dave, he'll introduce himself. We've asked him to go ahead and give us a presentation this afternoon on regional monitoring and the status of the consent order. A lot of what we've discussed in the past has been about the true waste effort. As we finish up the true waste effort, this time next year we'll be done with the 3706 campaign, June of 14. We're asking the state to engage us again in relooking at the milestones and consent order. And I believe we have Secretary Ryan on the slate for the September meeting to actually talk about his perspective. He's the Secretary of Environment for New Mexico. So this afternoon we'll have Mr. McEnroy give us a State of the Union address as far as the consent order and regional monitoring.
Thank you.
Thanks, Lee. I'm glad you clarified that we've been doing real good on the agenda as it pertains to the schedule, because I'm going to vary a little bit from what the agenda says as far as regional monitoring. The consent order doesn't do regional monitoring. That's in Mike Brandt's shop, and Mike's in the back. So if you want something on regional monitoring, I suggest we talk to Mike later and get him on the agenda. So what I'm going to do is a very brief consent order 101, if you will, run some of the new CAB members through our consent order, and then give you a brief description of some of the consent order projects underway, and then a very brief status of where we are as far as completing the consent order. So if that's all right with you, we do some regional studies that we use to help with our background studies and trying to find out what's anthropogenic contamination versus laboratory added, but we don't do monitoring. So I encourage you to get hold of Mike afterwards if that's really what you wanted. A little bit of background on our consent order. Our consent order is now 8 years old. It was issued back in 2005, and the original consent order had about 100 stipulated major milestones that had to be delivered. But those 100 milestones fed into additional milestones. Every year we get between 150 and 200 milestones added. Milestones equal either installation of something or a regulatory deliverable, but something that's enforceable under the consent order. The consent order is between NMED, DOE, and at the time University of California, and that now has been transferred to LANS, the UC piece. There's many legal provisions in the consent order. What's important to us is dispute resolution, which allows the laboratory and DOE, if they disagree with the state, to elevate it, our disagreement, to a higher level until it can be resolved. So if we ever did come to a serious disagreement, we thought the program was heading in the wrong direction, or we thought the consent order was being misinterpreted, we have that opportunity to elevate it. And then the final resolving party, or the final say, would be with the Secretary of Environment. It also has force majeure. Force majeure has a lot of pieces of it, but how we've used force majeure this year and in past years is we haven't been able to meet the schedule and the consent order because of something outside of our control, like wildfire. So we had to submit a force majeure this year when we weren't allowed to go to the field because of the conditions were so volatile that we might start a fire just driving a vehicle out there. When those conditions kick into effect, the state gives us a day-to-day slip until we're back into a normal state of operations. It also has an anti-deficiency clause in it, which is also important given the state of economy now, let's just say, with not receiving full funding from the government. We can have a funding number elevated to Congress to support our projects here, and they cannot be agreed upon by Congress or fulfilled. So in those cases, the state would allow for extensions to be granted until funding was received. We can be and have been in the past held to up to 15 stipulated penalties a year. That means there's 15 out of the roughly 150 deliverables that we owe the state every year that have immediate fines assessed to them if we miss a day. So for the first 30 days, it's $1,000 a day fined against the laboratory for missing every day. And then after 30 days, it goes up to $3,000 a day. So there's more incentive on those. Yeah.
Do you have a total amount since the inception of what fines have been paid?
Not on my fingertips. Let me get back with you on that. We have had a penalty assessed against us. It's been a few years now, but it dealt with the notification. We haven't missed any deliverables, but it dealt with a notification of the identification of chromium in the aquifer. So there was a time that was calculated for that, hey, didn't you recognize you were supposed to notify us on this newly identified contaminant? While it was notified in meetings, it wasn't notified through writing, and there were fines assessed for that. But let me find out what those were. And there's other ways to assess penalties against the laboratory as well, with civil penalties and criminal penalties as well. So anyway, the whole intent of the consent order was to accelerate the investigation and remediation of our nearly 2,200 sites at the laboratory, to prioritize which of those sites should we be investigating and cleaning up first. The order provides a minimum number of investigation samples that needs to be taken, and that you would have to have the results for in order to identify a remedy. And it also prescribes what level of cleanup that we would have to clean up to. The types of sites and the numbers of sites we have, we've got over, like I said, 2,100 sites. We've got landfills or material disposal areas. These seem to be the sites that gather the most interest. We call them MDAs. You've heard of MDAG. We just cleaned up MDAB and are getting ready to transfer it to the county. So our MDAs are made up of pits, shafts, trenches, and abandoned downhole experiments. So they're all not really landfill type excavations and disposals. Some of them are actually, TA-49 was a downhole experiment, and that's called MDA-AB. Wastewater treatment systems, probably where the majority of our sites fall into. It's septic tanks, it's drain lines, it's any sort of wastewater treatment plant or impoundments. So the lab itself had, I think, over 150 of these outfalls where wastewater actually daylighted and dumped into the canyons, and Mike's directorate has reduced those down to somewhere around a half a dozen now. So there's been and as they are reduced, then we go in and investigate and remediate any sort of residual contamination if necessary under those. So, and then there's areas associated with just past and present operations. You know, back in the 40s and 50s, people didn't really understand the severity of some of the contaminants or products at the time that they were working with, and as they finished with them, in some cases they got pushed off the side of the mesas. Other cases, they were spilled and just left to stay there, left in place. So we come back and investigate and remediate those sites. And the type of substances that we do clean up are radiological, chemical, heavy metals, and high explosives, and there's degradation products associated with all of those. The other things that we do under the consent order is do surface water protection, groundwater protection, and when I say protection, I mean monitoring. We do flow mitigation, which is, I'll talk about in a little bit into more detail, but those are things that we do that inhibit contaminants from moving off-site and cleaning up contaminants that are moved by surface water. Groundwater protection, we do regional groundwater monitoring and reporting, and we do monitoring associated with, if we leave contaminants in place, we would monitor the performance of those cap systems or make sure that contaminants don't move to the groundwater if we feel they're in a safe state and they can be left in place. And we also do remediation. As you know, my last presentation talked about the chrome remediation and study in Morton-Dad Sandia Canyon. So, natural resource damage, I added this because it's a very related program. NRDA is a program that deals with the loss of the word escapes me, loss of use of a certain piece of the environment. So as we're cleaning up the environment, soil, water, air, we make sure that it's cleaned up and would meet the intent of the Natural Resource Damage Assessment Act. So as we clean up water, we would want to make sure that there's been no loss or there would be no future loss of drinking water, and we would clean up to a standard to ensure that. So it's a related program.
Quick question.
Yeah.
The loss of use, that could be so varied, the infinite ways you could use a piece of land. Does this act define what the uses are that you
Right.
want to remediate?
It does. And probably the most broad of the resources that would be lost is a cultural resource.
Okay.
And so cultural is kind of the collection of how someone might use that property that's outside of drinking water or surface water standards or the soil standards for farming. The cultural has a little more broad interpretation than that.
If it had oil or gold in it, would that kind of thing be protected also? I mean, I know it's not likely, but I'm just
It would have to be cleaned up to a level that protected the workers going after the oil or the gold. So.
Okay, thank you.
So there's actually a coalition or committee, but there's a
Trustee.
The trustees council has been formed that has some of the Pueblos are on it, Foresters on it, Department of Energy, I think some of the municipalities, but we gave a presentation probably about 4 years ago about NRDA. We might be ripe for rediscussion because it is a relatively new act, and even the government is still kind of trying to figure out what it really means and how to deal with the requirements of that act. Is maybe a better way to say it.
Right. Okay. A little bit about the corrective action process and the how we go through the investigation cleanup that's required in the consent order. We characterize both the ground surface and the VADOS zone, which is ground surface to drinking or to the water supply. We characterize surface and groundwater both, and once that characterization, meaning sampling, is complete, we would recommend, after a risk assessment, whether a corrective action needed to take place or the risk assessment identified chemicals of concentration that don't warrant cleanup. We would make that recommendation. If it didn't warrant cleanup, if it warranted cleanup, we'd recommend a remediation, and then the state would have to agree with what we were recommending. So this little diagram down the right-hand side just shows we'd investigate, assess the risk, select the remedy. Once that remedy is selected, the state would have to agree with that remedy, and we'd complete the remedy and report on what was achieved, whether we achieved the remedy as expected by the state and stakeholders, write a report, and then they'd have to approve it. At that approval time is when we would recommend a certification of completion, and that's a process that the state has us go through that confirms that the state believes that we're complete with that site, and the state can say that we're done with that site with or without controls. Controls would be some of the monitoring that I talked about earlier, or they would be complete without controls, which means it's the land can be used however anyone chooses to use it. No controls would be required on that site. Some of the continuous improvements that we are currently going through is we always update to the most recent analytical methodologies, and so if we can get more sensitive approved EPA methodologies, we would be using those and sometimes going back to sites that we already characterized, using those improved methodologies to make sure earlier studies are confirmed. And the other thing that we do is where it does come into regional studies, we study the effect of forest fires, of urban development, regional PCB sampling, so we can understand what is actually added by the laboratory versus common to all either developed communities or everywhere in the environment, that we wouldn't be able to clean up the site to a level if it's existing everywhere in the environment. So an example of that is PCB in the water. Now, the stormwater requirement for cleanup for PCBs is in the part per trillion level, and we can find that part per trillion level in stormwater on Wheeler Peak. So, I mean, we know that's not a result of the laboratory, so we need to enter into discussions with the state on, okay, what's the next level we should be achieving, because the first standard that's out there is non-achievable. Okay, now we get into some of the projects underway this year that I'll bring you up to speed on. This first one is the activities that we call town sites, but I really think that this is all property that is not DOE property. We have sites on private property, we have sites belonging to the county, we have sites belonging to the Forest Service. Some of these sites were transferred back in the 50s. Some of the sites are still in our ownership and we'd like to transfer. And so it's various stages of ensuring historical cleanups are still warranted or still valid, or there's warranted cleanups and things weren't left in the best of conditions. So what this first picture is a shot of Ashley Pond back in the 40s, and you can see these labs around Ashley Pond. At the time, they were dumping into Ashley Pond. So this is kind of the stuff that we deal with daily in our town site or TA1 characterization. So all of around here was TA1 back in the 40s before they started moving out to the other tech areas farther outside of town. So this site was cleaned up in the 60s and the 70s, but recently they are undergoing the revamping of Ashley Pond and putting in stages and waterfalls, and they're making it deeper. And so that was another opportunity for us to go in and let's use our newest sampling techniques. And so I had guys go into the middle of Ashley Pond, take additional samples, let's characterize it yet one more time with latest technologies and make sure it's good, safe for not only the county's workers, but for county gatherings, as we all know that occur around the pond. And it was. So it came back, it proceeded on schedule, and that was a good thing. Some of the other stuff that we're doing around town, we had 292 sites around TA1. We've completed 224 of them, and the rest of them remain some very small cleanups, targeted cleanups. They're kind of off the side of the cliffs. And some of them are just confirming that we have extent on some of the very low concentration contamination that was in or around. These are condominiums around town where we're just getting extent of contamination or confirming that there's no contamination there. So there's another 59 or so in process, and we're hoping to wrap up that campaign either this year or next year, depending upon funding. And the money guy just walked in, so we could finish that up there, you know.
Sure.
The other thing I reported on last time was the chromium studies that we're doing and the actual pump and treat in Mortondad Canyon, Sandia Canyon area. We actually kicked off, we finished the R42 treatment system, started pumping I think it was the 21st of June, and we've pumped 360,000 gallons to date and treated that water. This was kind of the groundbreaking or the turning of the valve. This is treated water coming out of the treatment unit, and we're moving forward with that, getting a lot of really good data on when we do go full scale. If we go full scale pump and treat, we'll know where to put the full scale well to treat those contaminants. R28 is expected to come online mid to late August, and that will be pumping about 3 times the rate that our R42 is. So we're seeing some good data come out of that. We're treating all that water, like I said, and it's being land applied. So I think Mortondad Canyon is going to be the greenest canyon that we see if you were to look at an aerial map in the future.
Hey, where do you take the chromium-6 that you get?
It's kind of an exchange, the ion exchange vessel that we have. We go pick up a new one. They give us, we just trade. So it's, do you remember the company, Jeff?
Where do they take that chromium-6? I'm sorry.
It's managed as hazardous waste from that point forward, so it goes to a permitted TSD.
Okay, I just kind of wondered where you got rid of it.
It's part of a turnkey. It's part of a turnkey service, I think, by Kears.
The lab has contracts with a number of hazardous waste providers, so we cover the gig.
Okay. You're not sure where it doesn't go to WIP or something like that.
It's not regulated.
Okay.
How long do you expect that to have to run before you can turn it off?
We're gonna run R42 until the middle of August, maybe a little more, depending upon the data that we're getting out of the test. The state has expressed interest now that they may want us to run it to the end of August. We're initially looking at the middle of August to turn off R42. Then we're going to start pumping R28 at that time until the ground freezes and you can't land apply. Then we'll take over the winter to look at all the data gathered and determine whether we've got enough data to move forward, either putting in a full-scale pump and treat system, or if we want to run this scale for another season. That'll be determined with the state.
This is basically a pilot project. Okay.
It's going to interim measure.
Okay. The other piece of the interim measure is the Sandia grade control structure. And this is actually the area in which the Chrome-6 was introduced into the environment from the cooling towers. This is the wetlands in Sandia Canyon. And what we started to see was some head cutting and losing of that wetland as the stream was flowing through it. This was the area that a lot of the chrome was bound up and being converted to Chrome-3. We also have some PCB contamination in this wetland, and these wetlands are Mother Nature's way of converting with the degrading conditions or reducing conditions in these wetlands. Actually converts contaminants, stabilizes contaminants. So we want to make sure we didn't lose this wetland and let the contaminants move downstream and enter into the groundwater like the stuff that already is there. So we're building a series of 3 walls in the canyon out of sheet piling and concrete. This is an example of one of those walls after we dewatered a portion of the wetlands. And we pump that water around where these walls are going in, and it's a stair-step effect in the wetlands that'll keep the head from cutting, maintain that wetlands in place, and hopefully we'll have that for a long, long time. And that's this project's anticipated to be done in about a month. And we've experienced some setbacks on this with some of the rains we've had. We had a 1.6 inch rain event a couple weeks ago that we had water coming off the county landfill and just dumping into our construction site. So we had to pump that out, dry it out, and start over on some of the stuff. So we lost a little schedule with this one.
I don't understand what you mean by head from cutting. I mean, is that saying water's coming in and cutting a deep line through the middle?
You understand it, yeah.
Okay, well, I'm not sure.
It is. It's where the stream,
Spread out.
when we do have these larger events, the stream that's coming through the wetlands is coming through with such velocity that it's actually scoring out the bottom portion of the wetlands, and you can watch that wetlands retreat over time. And so what we're doing is going down to where the wetlands ended naturally before all the scoring took place, putting in these walls and allowing it to rejuvenate and stabilize. So what you'll have is a kind of a cascading trickle effect over those steps, and won't be able to head cut anymore. And all this vegetation will come back. We'll revegetate, but I imagine in a year or two from where we've done this in other places, you won't even see those walls in 2 years. You'll just see steps of cattails and willows.
So those are perpendicular to the water flow? Those walls?
They are,
to
yeah.
Push it out?
Yeah, they are. So what you'll have is the water coming across these concrete capped lids on here, and it'll just cascade over, and it'll go to the next step. The other thing that's going on is there's a lot less water being generated by the computing facilities and coming off the parking lots because some of our BMP's upstream. This will allow the water to sit in that area longer to feed the root systems of those plants. So we can have the same wetlands with less water moving down canyon. Excuse me. I'm sorry. I'll cover this.
What was that?
Surface water protection, it's still not gone, is it? Excuse me. Okay, some of our surface water protection projects this year, worth noting. I've got a couple pictures of our projects. We've got a flume. I still am not going to figure these buttons out. A flume in this lower corner, and these flumes are a way that the lab monitors the water moving through, in and out of the lab. We've got about 24 of those flumes around the laboratory, which is part of our network gauge station. Our gauge stations have about 50 locations where we monitor surface water flow at the lab. This is called a low-head weir, and this is down at the White Rock Y, if you've seen that down at the White Rock Y. These are actually retention structures that we put around the laboratory that capture sediment, and it's kind of our last line of defense, trying to stop sediment from moving off the laboratory property. This is a picture of removing the sediment, and you can see that front end loader down there and just how deep of sediment that is. So we remove that every couple of years. We'll dig out that sediment, we'll sample it, and depending upon the results, we'll manage that accordingly. I will tell you, this is one of these places where We go back and we have new regulations, or we have new sampling methodologies. What we're saying is you can clean up a site and meet all the soil cleanup levels for residential land use, but if it rains really hard on that site and that soil runs off and you collect it in stormwater, you can fail a stormwater regulatory standard. So it sounds a little funny, but we can dig up this sediment because it'll bust a stormwater standard, but we'll take that sediment out, sample it, it's clean, we move it back up the canyon to a borrow source where it can no longer migrate. So we're digging up something because it's going to fail the surface water standard when mixed with water, but won't fail we got people lined up that want to use this soil in their gardens, and I would too. It's the most fertile soil that you can see. It's coming down from the fire. It's got ash in it. It's really nice stuff, but it will blow a surface water standard. Some of the other projects that we do, we have over 500 of these stormwater controls in place around the laboratory that do nothing but settle the storms that we have, allow the water to pond and infiltrate instead of gully and join with other sources to really get the stuff moving down the arroyos. So we've got 3 flumes that help Buckman monitor their water treatment system, and those flumes will shoot, at least one of them will shoot a signal to the Buckman plant, let them know that there's water coming down, and then Buckman has the opportunity to close the gates or keep the gates open depending on where that water is coming from. We had an event last week before last. It was the same event that I mentioned, that we had a 1.6-inch storm. Well, we've got 2 flumes that are on the lab boundary, and then one right before you hit the Rio on San Ildefonso property. The one on San Ildefonso property flowed about 8 feet deep, so it was over our flume by 2.5 feet. We were able to tell by the other upstream flumes that event came from Wahi Canyon, and nothing came off of the laboratory. So that's good for the lab to look at all these improvements that we've done. Are controlling the stormwater, and also allowed Buckman to make the decision whether, knowing this water wasn't coming off the lab, do they want to keep their gates open or not? And I think they've been closed for a while because of the drought. But last year when he had a similar storm, they chose to close them just because of the ash that was coming down Wahi Canyon from the fire last year. Groundwater protection. This is the program that detected the chromium in Mortondad Canyon. It also detected RDX and the perched water up in TA-16. So we see this as a very valuable program. Over 120 wells are monitored. We've got 360 samples and sample locations that are taken every year and reported to the state. And we've put in 104 new locations since the consent order. So very active program, negotiated annually based on what we see with the state, where we need to sample and what we need to sample and what duration we need to sample or frequency. One of our last projects that I'll talk about today that we're working on is MDA-B. And MDA-B, as you know, was a 6-acre landfill out on DP Road that we removed about 47,000 cubic yards of waste from. It was one of the lab's earliest landfills. That project was funded by American Recovery Act funds. However, activities as of late are getting it ready for that area, ready for land transfer. So that site, those 6 acres were cleaned up to a residential standard, and the enclosures that was used to excavate the waste were removed this year, and footings pulled out, and base course and stormwater plans applied to the site. And I think that property now is slated to be transferred maybe in 2014, this time. So the county's real eager to get their hands on that for economic development purposes. So a little bit of the status. One thing that we do, because we have so many sites and so many watersheds and miles of drainages, is we do our risk assessments by watershed. And so we have a number of watersheds with smooths in that we track whether we're complete in those watersheds or not. So this little pie chart is a way that I kind of keep track of what's still out there, what watershed can we finish completely. And these light blue watersheds that you can see here, everything that's light blue, all the smooths in those watershed are done and have been signed off on by the state. The blue depicts how much we're complete with, and if you looked at the total, out of 2139, we've got 850 sites in various stages of characterization, cleanup. We're waiting on the state to make the determination whether we're done or not. So that helps me look for the best way that I can go after footprint reduction and get large areas cleaned up. And you actually get some of the requirements for laboratory workers reduced if you can clean up the work site that they're in. So like I say, out of 2139, we've got 850 remaining. Out of those, there were 26 MDAs. We've got 10 of those MDAs. Material disposal areas complete. We got 4 with CMEs, corrective measure evaluations, waiting and submitted at the state, which means the characterization is complete and the lab has forwarded a recommendation to the state. And we've got 2 others that are just about ready to be submitted to the state, and 10 are ongoing that are still being investigated, or the smaller size MDAs that we think that we can just handle through some of our normal cleanup, that there would be a presumptive remedy associated with that MDA and wouldn't have to go out for the full-blown public involvement and agreement. And when I talk about a presumptive remedy for a material disposal area, almost always, if not always, means that we're going to clean up that disposal area rather than cap it. To cap it, we'd have to get input from stakeholders. So that's all I have.